Hello, Vaquero Kids. So, we're going to do a little bit of a review of what we've learned this week, and we're going to be discussing the states of matter. Scientists have learned that all matter is made up of tiny particles. These particles are arranged in different ways and they move. The form in which particles are arranged and move is called a phase or a state of matter. Three states of matter are solid, liquid, and gas. Most substances on Earth exist naturally in only one phase. For example, gold and lead exist naturally as solids on Earth. Helium exists naturally as a gas on Earth. However, rock exists as a liquid inside Earth and as a liquid or solid on Earth's surface. Water exists naturally in three states. Liquid water is the same substance as the solid called ice and the gas called water vapor. You can predict how water will change states when heating or cooling it. If you add heat to ice, the ice melts. If you add heat to liquid water, the water boils and becomes water vapor. The steam that rises from the boiling pot of water is not water vapor, it is tiny droplets of liquid water. You can see water vapor because it is an invisible gas. Water vapor is one of the gases in air. When water vapor in the air comes in contact with cooler air or a cooler object, the water vapor can cool down and change into liquid water. That is what causes the tiny droplets of water to form on the outside of a cold glass of water. The water vapor in the air comes in contact with the cooler outside of the glass, and the water vapor cools down and condenses or changes into drops of liquid water. Solid, liquid, and gases. Solid. At a temperature of 0 degrees Celsius or below, the shape of an ice cube is the same whether it is on a plate or in a container. A solid is matter that has definite shape and usually takes up definite amount of space. Its particles are closely packed together. The particles have some energy. They move back and forth, but they do not change places with one another. This is the example. If you look up here, this is what a solid looks like, okay? So it is made up of tiny particles and they are moving, except they're compacted so tight together that we don't see them moving. You cannot see the individual particles in a solid. This drawing shows that they are tightly packed and held together. This is the example of water as a solid, like the ice cube. If the particles are packed close together, they are moving, but we don't see that. They're just so tightly packed that they're just held together as a solid. Liquids. In contrast to ice, water takes the shape of the container it is in. If you pour water from a pitcher into a glass, the shape of the water changes. The volume of the water stays the same. Matter that does not have a definite shape but takes up a definite amount of space is a liquid. In a liquid, the particles are not held in place as a solid. The particles of a liquid are able to slide past one another. In many substances, the particles are packed more tightly in the solid state than in the liquid state. Water is an exception. The particles in liquid water are a little closer together than in solid water. Right here, you can see the particles in the liquid. Either the particles are close to each other, but they are not held tightly together. And as you can see in the solid where they form a definite shape, the particles in water can move a little more than they do, and it's not held as tight. Gases. In the gas state, water is called water vapor. It is invisible. Water vapor and several other gases make up the air that is all around us. Like a liquid, a gas takes the shape of its container. In contrast to a liquid, a gas expands to fill whatever space is available. A gas always fills the container it is in. The particles in a gas are very far apart from one another and move in all directions. Particles in gas move more easily and quickly than those in liquid. The particles in a gas are far apart. Even if you could see them, you could not see the particles arranged in any special way. And you can see here the particles, they're just going all over, like bouncing around everywhere. Here we are looking, it says label the states of matter. Label the states of matter. Okay, so I'm going to take a quick screenshot of this so that we can label it quickly and then we will return. All right, let's see. Okay, so we can see here if we're labeling the states of matter. This is very simple. Here we can see that this is the liquid. The water is the liquid. This would be the gas. I'm sorry. This would be the gas. I was going to say gases, but it's gas. And then over here we have the ice, which is the solid. All right. Okay, so let's move on. Changes of state. So this is again the solid. We have the solid down here, the liquid, and gas. So we're going to look at how the states of matter can change. And we're going to use water as our example. Suppose that you freeze water into an ice cube and then let it melt. The liquid that results, it's still water. So it doesn't matter if it's the ice cube or it's liquid water, it's still water. What causes the particles of a substance to be in one state rather than another, energy can cause the particles in a substance to move faster and farther apart. Substances change state when enough heat is added or taken away. For example, if you put liquid water into the freezer to remove the heat and make ice, you add energy to water to raise the temperature. If you boil the water in a pot, some of the water becomes water vapor. Changes of state are examples of physical changes that can be reversed, adding or removing energy. Every substance changes state at a different temperature. So let's look over here. It says you can contrast the different temperatures in different states of matter. For example, at 100 degrees Celsius at sea level, water boils and water vapor condenses. Here we have water. Between 0 degrees Celsius and 100 degrees Celsius, water is a liquid. So between these two temperatures, water is just water. Okay, up here when it goes above 100 degrees Celsius, then it begins to boil and form water vapor. Down here I can see it says at 0 degrees Celsius, water freezes into ice and ice melts into water. Okay, so when we're below 0 or below, then we get ice. Melting and boiling points. The melting point and boiling point of a substance are physical properties that help identify the substances. The melting point is the temperature at which a substance changes from a solid to a liquid. The temperature at which a substance melts is the same temperature at which it freezes or changes from a liquid to a solid. The boiling point is the temperature at which a substance changes from a liquid to a gas. This temperature is also the temperature at which the substance changes from a gas back to a liquid. Substances have different melting and boiling points. For example, tin melts at approximately 230 degrees Celsius. It boils at approximately 2270 degrees Celsius. These are different from the melting and boiling points of water. Okay, So today I'm going to put questions in your assignment. You can go back and watch this video to look for the answers. And I'm also going to be putting the photos of these pages that I just read into your assignment. You can go back there and read them at your own pace.